Hi, in this video, we want to take a look at a case study using Leaflet in R. All right, so I went to the City of Orlando's website and I downloaded crime data. And I want to use Leaflet to take a look at where are the crimes happening, what are the crimes, and get a feel for what's going on. Okay, so in the data set, it has from 2010 to 2020. And here's the website that I got it. So it's from the cityoforlando.net. And you can also there, I got the shapefile for the boundaries for the city. All right, so what I'm going to do, first, I'm going to load the shapefile because that'll be like the lower level for the map so I can see the city limits. Then what I'm going to do, I'm going to plot the different types of crimes on top of that by the location that they happened, because the data set includes latitude and longitude. All right, so I want to load the GeoJSON data as a spatial polygon data frame. Okay, so this is a very particular, special, powerful data storage format for geospatial data. Now to read this, I'm going to need to use the RGDAL package. I'm going to read OGR. All right, so if I have a GeoJSON data set in R, one of the best choices I can go with is RGDAL read OGR. Now I'm going to store that. So the output is going to be a spatial polygons data frame. And one thing I like to do whenever I'm doing data science, I like to name my objects with what it is in terms of structure and then a descriptive name. That's something that I have found to be very good, very wise practice, so that like 6 months from now, when I look at my code and I go, hey, what is this? I know what it is. So my naming convention is structure, then description. So here, there's the structure of it. So when 6 months from now, I go looking at my code, I know exactly what that object is, and I know that pertains to Orlando. Now, I could go a little bit deeper, say it's like the city limits or anything else, but naming in computer coding is always a tricky business. I'm just going to stop at Orlando so I don't type too much. All right, so after I do this, we can see that we have an OGR data source from GeoJSON, and it's saying where it got it. And it says that there is a layer called Orlando city limits. All right, so there could be multiple layers inside these objects. And here there's only one layer, it's Orlando city limits. The data frame has one feature and one field. Okay, so the data set that's inside this is empty, honestly. That's what's really going on. So the spatial polygons data frame has the option of having a polygon shapefile and a data set that connects with that polygon. That makes it very easy for us to work with as we go through and we start plotting data. Here, we don't have anything. So what I'm going to do, I'm going to load in that crime data and I'm going to put it in that slot for the data frame. All right, so now let's go ahead and take a look at what I have. So I want to use the str function. So I want to look at the structure and I'm going to specify the object I want, and I'm going to specify the max level. Or if you work with the str function, you know that if I just leave it at default levels, it can spit out more than I actually want to look at. What I do in real practice when I'm looking at an object, I put max level to 0, then 1, then 2, then 3, until I'm satisfied that I know enough about what I'm interested in, what I'm working with. So here for this video, I chose to stop at 3. When I was preparing for the video, I went deeper than that until I felt like I knew what was inside the object. All right, so when we look at the structure, we can see that, it's a spatial polygon data frame, not surprising. It has 5 slots. There's data, polygons, plot order, bounding box, and then the projection in terms of representing the curved earth with a flat map. All right, so the data, when I look at it, I see that it's a data frame, but there's one observation and one variable. It's really an empty data frame. It's useless. It's just called City of Orlando. Now the polygon, we can see that it's a list. So I only have one polygon going on in this, and it's this is coming from the polygons from the SP package, and it has 5 slots. If I would have put max level to, let's say, 4 or 5, we would be able to see those slots. But I stopped for the video because it blasts a lot of information at us, and I felt like it would distract the video. Now the plot order is just an integer of 1. All right, so when things are more complicated, plot order will matter. And so here, well, the plot order, what this is specifying, if I have multiple polygons to lay down, if they lie on top of each other, order matters. And this specifies the order. Now the bounding box indicates the maximum latitude and longitude of the map. And then the projection string just tells us how to set up our projections. I have another video using ggplot in terms of projections. All right, so now I've got the polygon data frame stored in my machine. Let's go ahead and get leaflet going. So I'm going to call leaflet with a library function. Now, as a quick and dirty map, what I'm going to do is I'm just going to pass my spatial polygons data frame to leaflet, and I'm going to add polygons. All right, so this specifies the polygon. This puts it into leaflet using the piping function, and then I tell leaflet, go ahead and actually build the polygons. So if I didn't have this last bit, it would create a blank map with no images. Not very informative. But so here, now we can see what the boundary of Orlando is. So it's interesting that we almost have 2 islands in Orlando for our map. Huh. Well, that's not really as informative as we would like, so let's kick it up a notch. All right, so now what I'm going to do is I'm going to pass the spatial data frame to leaflet. Now I'm going to add tiles, and I'm using the default tiles on this. So this is the regular standard default base tile that I could use, and then I add polygons on top of that. So now remember, when I start specifying things, order matters. The leaflet is going to execute it in the order that I give it to, and so whatever I want on top, I want to put last. Okay, so here I can see, get an idea of what's going on. I can see where different neighborhoods are. If I want, I can zoom in. I can move around. Like if I wanted to go study the lake in Baldwin Park, so I can go take a walk around it, I can do that. Very nice. And we can see that part of Baldwin Park is not actually in Orlando. Huh, I didn't know that. All right, well, I'm going to be plotting data on top of this. I want that data to pop. I don't want conflicting colors. So what I'm going to do, I'm going to put down a black and white map. This is so that when I put down a red dot or blue dot, the color of the dot pops and doesn't blend in with the background. All right, so to do that, I'm going to change my code that instead of just adding tiles, I'm going to add provider tiles stamen. And that is a good black and white map. Now, also something I'm going to do, I'm going to change the weight to 1. What this does, this puts the boundary, this puts the edge at a smaller boundary. You see how thick it is? I find that kind of distracting. I find it obstructive for my purpose. So I'm going to go ahead and reduce the weight. If I want to, I can make it even weight 0 if I don't want it. And then I'm going to choose the color blue. I played with several colors. I felt like blue was actually a pretty good choice on this. All right, so we can look at it, and you'll notice that we have different features plotted on the map that's underneath the polygon. All right, so now my next goal is to take my data and actually put it on top of this map here. All right, so now let's go ahead and load the crime data. All right, so remember this came from the City of Orlando's website. I chose to use fread because it was a large enough data set that it took a little bit of time to read in. So I went ahead and went with data.table. If you're looking for speed in reading and writing, data.table is almost always a good choice. Now, something I like to do, I like to load everything in as a character. That way, things like social security numbers, ID numbers, case numbers, automatically coded as IDs instead of some numeric object. So like social security number, if it was just straight numbers with no hyphens, that R might interpret that as a numeric number where I could do addition and subtraction. And in that case, leading zeros could be dropped. Well, I don't want that to happen, so I load everything in as a character. Also, I don't want to have to fight with levels of my data, so I don't use factors. Now, something I like to do, and I do this a lot, and I do this professionally, I find this is very good practice. I like to standardize my column names. I find that this makes it much easier down the road for me to know what I'm looking at, so that I know that I'm looking at a column name because I have the same uppercase, lowercase, underscore format every single time. So the janitor make clean names function, what it does is it will put things so that I have capital for the beginning of a word, lowercase for everything else, and it will put in underscores for spaces. It will also remove characters that are not syntactically correct for use in R. So some packages want column names to be syntactically correct. Okay, the automatic light came on. There we go. There we go. So now, so syntactically correct names are good practice in R because it makes some functions such as random forest work better with those. You can get errors if you do not have syntactically correct names. So I choose to use the janitor function to clean things up. And by putting case none, it goes with the underscore for spaces. It has a whole bunch of different options. Use the one that you feel works best for you. I recommend be consistent from project to project. All right, so now, if you look at this data set, it has latitude and longitude for some crimes, but it doesn't have them for others. Okay, so what I'm going to do for the purpose of this video, I'm just going to filter out where I don't have the location. Now, if this was a statistical study, this would be invoking sample bias automatically. So this would be a big deal. So if I was doing this for rigorous statistical analysis, this step right here, I would have to have a pretty good justification for why it's not giving me sample bias or why that bias is not a problem for my project. All right, so if I was working on a real life project, I would have to geocode the addresses that aren't there. So I'd have to either pass them to the US Census site, use some GIS software, or use Google's API to take care of it. I didn't feel like putting in the effort. I didn't feel like paying Google, and I don't have the GIS software on my personal computer, so I didn't bother with it. All right, so here, if this was a real statistical analysis, which is not, just a video, this would be invoking sample bias. So, but when I look at this further, like down after I get the results, I need to keep that in my mind as I look at, know that I filtered out all the locations that did not have geocoded latitude and longitude. All right, so now the data set is big enough that it's going to take a while for it to process. So just to clean things up, to make it a little bit easier on me, I'm only going to work with 2020. All right, I mean, that was an interesting year. So, the distribution of crimes will more than likely be different than 2019 and 2021, but it's still informative as is. So here I'm only looking at 2020, and honestly, 2020 is probably not comparable to other years anyway, so it's good to isolate it. Now, what I'm going to do, I have latitude and longitude, how it's coded inside the data set. It's in one column, there's parentheses with a comma in between. So what I'm going to do, I'm going to get rid of the parentheses and do a string split on the comma. All right, so here, this replace all gets rid of the parentheses, and then the split, str split fixed, splits up everything on the comma, so that I have latitude and longitude in two separate columns. And then I define them as latitude and longitude. Now I've got all of my data. So let's go ahead and start taking a look at what do I have. Well, I looked at it, and if I make a table and make a proportional table, I can see that theft accounted for about 54% of the crimes, assault 14%, fraud 8%, narcotics 8%, burglary 7%, vehicle theft 6%, robbery 3%. Now, arson, homicide, kidnapping, and embezzlement really are rather low in the amount that they account for. And for the purpose of plotting things, like embezzlement's so rare in this data set that do I really even want to consider this? Do I want to keep this? Honestly, no, I don't. There's so few cases that I'm going to bend them just so that I don't have like a lot of levels when it doesn't make up a lot of mass. So, I mean, now, even though homicide is very interesting, it proportionally doesn't account for a lot. So it's less than, so it's, about a 0.1% of the data. And that's after removing the values without the location. All right, so what I'm going to do, I'm going to take the embezzlement, the bribery, homicide, arson, and robbery, and put these all into one group. I'm going to call it other, and just so that it's a little bit, it's a simpler categorical data set, I'm bending these all together. So now let's take a look at how that changed things. So you'll notice that, theft, assault, fraud, narcotics, burglary, and vehicle theft, they all stay the same on their proportions, but the rest are all bent together in about 3%. A good rule of thumb when you're doing stuff like this is you want your other category, if it's possible, to be your smallest category, and you want it, like, how I chose the ones to go into the other category was that if I added vehicle theft to other, that would exceed burglary. So that was my signal that I've bent enough. If I add any more into other would not be the smallest, therefore I stopped. All right, so now let's go ahead and let's define what colors I'm going to use for this plot. All right, so I'm going to use the Viridis Light package. So this has several color palettes to work with. I chose Inferno just because I thought it'd be fun to work with. And so I'm going to get for each crime category, I'm going to get a color. I'm going to store it in the V-color data set. And I'm going to take that table that I created and put the names from this table as the names of my color. So something that's happening is that the Inferno color palette, goes from light to dark, and that light to dark corresponds to the number of observations for each crime. So that way, that gives me a feel as I look at my map in the future, I can see which one has greater crimes in it. And so now to attach color into my data set, what I'm going to do, I'm going to take that vector of color, I'm going to index on the category, which you'll notice I just put in as the names, and then I'm going to make that into a new column called color. And I'm also going to create a label for each of my points on the map. I'm going to have the case number, the offense type, which is different than category. So offense type is nested within offense category for this. I'm working with offense category for mapping because it has fewer levels. It'll be a little bit simpler for the programming, but I'm including offense type in the information when the user starts digging in. And also I'm going to include the date and time of the offense. All right, so now on this next step, remember that that data set that I had in my spatial polygon data frame, it had an empty data set. That's not useful. So what I'm going to do to get the full power of a spatial polygons data frame going, I'm going to define my data to be the data that I'm working with statistically. Now what I'm going to do, I'm going to build the map twice. Once with clustering, once with overlays. All right, so playing around with leaflet, I could not get clustering and overlays to work at the same time. Therefore, I mean, I got the code to run, but it didn't work the way I wanted it to, so I broke it up in two separate maps. If this was a real project, I have to pick one. All right, so I'm going to take my spatial polygon data frame. I'm going to build the map. I've got the polygon. So this we've already done so far. Now what I'm going to do, I'm going to add circle markers. I'm going to say the radius is 2. I just played around with the numbers to see what worked. I felt like 2 was a good choice. I'm going to use a column of the data to specify the group. I'm going to use that column of the data to specify the color. So I'm using that column of data for the label, and the longitude and latitude columns as latitude and longitude. All right, so here, if you look at the previous videos and you look at examples from a lot of leaflet examples that you'll see, most of the time people are breaking this stuff up into multiple sets, and they basically make a subset for each group. Because I have group as an item in here, I'm able to get this done in one shot. So this is very nice. Now here, this is different from the option of the upcoming map. I'm going to use the cluster options, make cluster options. What this is going to do when I zoom out, when I go back, the points are going to merge into bigger points so that I get a sense of where they're at, but I don't get a whole jumble of points on my map. So now let's actually look at the map itself. Okay, so when I look at this, so let's look at the small one. We see that there's 4 points over here, and then we've got 58 points here. And notice that when I hover over it, the polygon that contains all the points gets highlighted. Here you can barely see it, but it's there underneath the 58. Then we get to the 229. Then here, all right, that's a much bigger polygon. And then we get over here, and notice that there is a little bit of overlap. That's okay. So now let's zoom in. All right, so something I can do is, you'll notice that the polygons change each time I zoom in. Zoom in again. Keep on zooming in. Every time that I see a number, there's more than one dot. All right, so here I can see that there was a false pretense to swindle confidence game, and this was on 9/16. If I click, let's say here, I can see that this was theft from motor vehicle, exerts parts accessory, and that was on 10/10. We can keep zooming in. I can get information on it. So this was drug equipment. And I'm having trouble getting this one to go. Oh, here's another one. Simple assault. Pocket picking. And so these lines indicate that these are happening at the same location in terms of the data set. So the data indicates that this latitude and longitude is where a lot of crime is happening. So let's see, what have we got? So we have aggravated assaults, all other larceny, robbery, all other larceny, drugs, narcotics, all other larceny, simple assault, shoplifting. So this is along South Orange Avenue between Church Street and Pine Street. Shoplifting. So a lot of people, you'll know that this, if you know Orlando, this is a very active area where there's a lot of people. So the red corresponds to narcotics. We see purple is motor was like a motor vehicle theft, it looks like. All right, so now that is using the cluster option. Now let's do the same thing, but with overlay. So now my code is the same, except for one critical difference. Well, actually two differences. You'll notice first and foremost, I don't have the cluster option. Also, I have an add layers control. What I'm doing, I'm putting down the overlay groups that I have that's coming from that sorted table. I'm taking the names from the table and I'm sorting them so that the most frequent crime category appears at the top when I click on it. The rev is to reverse the order of the vector. Okay, so here is all of the data for 2020 with latitude and longitude included in the data set. And so if I look here, we can see that theft is yellow, other is dark. So the lighter colored points correspond to the more frequent infractions. And so we have theft. I can look around the different types of theft, shoplifting, all other larceny, theft from motor vehicle. Let's see what's here, all other larceny. Look at assault, simple assault. That's like at the airport. That's interesting. Fraud, false pretense, swindle, confidence game, narcotics. Oh, no narcotics at the plane. Huh. It's interesting. We're here at goldenrod. Burglary. Let's see. Vehicle theft. Oh, there's a bunch at the airport. Huh, that's interesting. And other. So robbery. A lot of these are going to be robbery because proportionally. Arson. Hey, oh, lights went out again. All right, so trying to spot homicide. I think that'd be interesting. But we can zoom in. So I am interested in things that are going on at the airport. All right, so we can see that we've got some overlapping. That means that they were recorded at the same location, or the addresses were geocoded at the same location. So we have all other larceny, all other larceny. Simple assault, got a couple of simple assault cases. Fraud, probably people trying to swindle tourists more than likely. That'd be my guess. Oh, hey, there's a vehicle theft here. Other, all right. And, I can play around, take a look, see if I can identify any patterns, find something interesting. All right, well, that's all I've got for you. Take care and goodbye.